Hello, learners. Welcome to All About Java, a beginner's guide to learning Java programming with me, Apurva Barve. By now, you must have become familiar with the pattern of this lecture series. Every video in this series deals with some programming concept of the Java language and explains its significance and syntax. Keeping with this pattern, in today's video, we are going to take a look at the two most crucial aspects of any programming language. The first one of it being the variables. We are going to understand what Java does to its variables, what are the different types of variables, and we are also going to understand a very important concept of type inference, which was introduced in Java some time back. And finally, we will talk about what are the types of the variables. So, why wait? Let's deep dive. If you recall, in our previous lesson, we learned about identifiers and literals. We said that identifier is the label, that is a name given to any part, while literal represents the value. These two, when put together, form one more entity, and that is a variable. We label the variable with an identifier and give it a value from the literal part. Variables in our program do the most important task of holding the data. This data is almost always read or referred to or used to perform some business related functions, or it is modified as a result of some business operation. The basic syntax of variable is the data type of the variable. These are the primitive data types, any of it, or the class name. So let's stick to the basic syntax right now. Let us say these are the basic data types, the identifier, and you may or may not give the variable some initialization value. So this entire thing with the semicolon at the end comprises of the proper syntax of a variable declaration in Java. These are some allowed forms of variable declarations. So here if you see in the first form, I have only given a data type and the identifier followed by a semicolon. I haven't assigned this variable x any value. In the next one, I have given three variables of the same data type and they are comma separated. This is allowed in Java or for that matter in any programming language. Next, I have a double data type and I have declared a variable, given it some value, initialization value, comma, another variable, some initialization value, comma, one more variable, some initialization value. So I can actually have n number of variables of the same data type declared and initialized on the same line, on the same code statement. This is also allowed. And finally, if you see, this is something that is happening at runtime. So this variable sum, which is of the type int, assumes the value a plus b plus c at runtime. So these are the dynamic variables which are again allowed in Java and in any programming language. So these are some allowed variable declaration patterns. Every variable has its scope. So when the scope of that variable is entered, the variable is created. And when you step out of that scope, the variable is destroyed. We will have to remember this fundamental rule when we are dealing with variables. And that is why we studied code blocks in the previous video. We tried to understand what was the scope of a code block, and the scope is significant. It is indicated by the open close curly braces. So we have to remember that the variable will thrive within those curly braces, no matter what is the code block that is written around it. Java introduced an important concept of type inference specifically for local variables. Let's take an example to understand this. In front of you, you have a small business method. In this business method, I'm returning the value int. This is the name of the method, add marks, and this method takes three parameters of the data type int. The name of the first parameter is eng, second being maths, third being science. These three are the parameters of the method add marks. When at runtime some value is passed to the add marks method, those values are called as arguments coming into the method. So when you declare, it is the parameters, and at runtime, the incoming values are called as arguments. All right, I enter the add marks method, and within that, as you can see, this is a dynamic variable int sum, and this variable sum holds the addition of the three incoming parameters to this method. Finally, when I'm ready with some addition, I return it from my method. So this is another thing that we have to observe about writing our business methods. A business method can either use the value that it has got within it, or it can return the value so that further business operations can happen using the value that is being returned by the business method. In order to return a value to the calling method, Java uses the keyword return followed by the variable or the actual value. Now, whatever is the data type of that variable or the actual value, it is mandatory that we present the same data type in the return or in the data type section of the business of the method signature. So I cannot write void here and put in a return statement. My compiler is going to complain. Also, I cannot return an integer, a float or a double value or a string value here and say I'm going to return int. So everything here, this data type and the data type of the value which you're actually returning, the value that you specify in front of the return statement, they have to match. All right, so take a proper look at this code snippet. We are still trying to understand type inference, which happens in case of local variables. So in my add marks business method, I have 1, 2, 3, and 4 local variables. Now, what is a local variable? What are the other types of variables? We will talk about it little later in this video. But right now, just hang on and assume and take it from me that we have 4 local variables here, wherein the sum variable is a dynamic variable. I have declared it as int, and it gets its value only after some value is passed to the incoming parameters, and it adds those values. So this is a typical business method. Post Java or from Java 10, I should say, from Java 10, Java coders made a small change to the local variables. In order to keep up with the changing programming variations in languages such as Python, Java 10 introduced the syntax for a context-sensitive keyword where. Let's understand how the shift has happened here. I have a modified piece of code. Even now, I have my business method, add marks. I'm taking in 3 parameters, but look at the way sum is declared. I no longer use a specific data type while declaring a local variable. I perform my calculations, I assign it a value, and when a value is assigned to a local variable, the data type of that variable is resolved dynamically depending on the data type of the value that is being assigned to the variable. So here, instead of saying English plus maths plus science, if I would have said sum is equal to hello world, then the data type of the variable sum would have been string. Right now, here it is going to be int. So this is what we call as type inference. Due to this, the overhead of declaring and initializing local variables before using them is totally removed. We can now focus on getting the business part done while the type of the concerned local variable is determined at runtime. We are going to use this notation henceforth in our future examples. So it is important that you understand the difference between the current example, which makes use of the where keyword, and the previous example where the where keyword was missing. We are still doing the same thing with our business function. But this is what Java means by type inference. And this was done to keep the language on par with languages like Python, which come in with the inbuilt feature of type inference. This was introduced in Java 10. So we have seen what is a variable, we have seen what is type inference, and now let us go ahead and talk about what are the types of variables in Java. All right. So, in order to understand what are the types of variables, we will have to give you an example. But before that, let us first remember that Java treats its variables on three levels. We have the class, the instance, and the local variables, which we have seen just now in the previous examples. So the example that we are going to do now, a small example that we are going to do now, will help us understand all the three concepts in a better manner. So let's say there is a bakery shop in our town. Okay. This bakery shop has three bakers, baker 1, baker 2, and baker 3. Every morning, each of this baker goes to the inventory and gets the much needed supply of raw materials, which he will use to bake breads throughout the day. Once the supply is ready, the baker uses only his supply to bake the number of bread loaves. The bakers cannot share their raw materials with each other. So the raw materials that every baker uses is very personal to the function of baking a bread loaf. Are we still with are you still with me here? All right. So we have a bakery shop which has got three bakers. Every single morning, every baker will go to the inventory, get as much supply as he needs for baking the number of loaves for that day. The bakers do not share their raw materials with each other. Okay. Now, in the bakery shop, we have a board, a black board. Once any baker is done baking one lot of bread loaves, he is expected to update the number of loaves on this board. So let's say the first baker finishes baking 30 loaves. He comes to the board and writes 30 on it. After some time, the second baker finishes baking his loaves, and he also manages to get 30. So he writes 30 plus 30, so he writes 60 on the board. Finally, the third baker manages to bake 40 loaves. So he comes to the board, erases 60, adds his 40, and puts down the number 100 on the board. So now we have a common area, a common board where 100 is the number put down by the bakers to signify that we can sell 100 loaves of bread today. So by looking at this number, the bakery receptionist or the bakery person, counter person knows how many bread loaves can be sold on that day. Are you still with me? If yes, then mapping this example now to local, instance, and class variables will not be difficult. Let's go back to the raw material quantity. Now, whatever raw material every baker gets on his table is used for doing a single business function, and that is of baking the bread loaves. This business function is carried out separately, individually by every baker using whatever raw material he gets access to at the beginning of the day. This highly personalized data is labeled as local variables. Local variables have the smallest scope in any programming language. They belong for a specific method. So here, let's say the method is baking. And once the method is achieved, once the method is over, the local variables are destroyed. They are no longer active. So each time when the baker comes to the table every morning, the baker needs a fresh stock of raw materials. And whatever raw materials he uses for that day, those raw materials get over during the act of baking. So this is how local variables are. They're very centric to the function in which they are born, they are used, and they are destroyed. Okay? All right. Next, let us talk about instance variables. Instance variables are a level higher to the local variables. But in object-oriented programming, instance means object and object means instance. So when we say instance variables, we are talking about the object variables, variables that are copied, the variables that are present in every object. So let's say number of loaves baked. This count is present with every baker, and every baker modifies or has his own copy of this count, which is then given or written on the board. So the first baker's data is 30. The second baker's data is also 30, while the fourth baker's data is 40. So this is the instance variable for you, where every instance, every object has its own values in the variable. And every object gets its own copy of that variable, of the instance variables in a class. Instance variables, because they belong to the instance, to the object, are alive, they are active, they are accessible till the time the object is accessible. Once the object is destroyed, the instance variables belonging to that object are also destroyed. However, instance variables have a bigger scope than that of the local variables. Are we good till here? If yes, then we can go ahead and talk about class variables. Now, this board, which is maintained in the bakery, is a central board to hold common data, common information. This information is modified or read or accessed by the different objects. But if any of these bakers wants to take a quick look of how many loaves do we have in the bakery today, this object, baker, needs to take a look at the value written on the board. This kind of shared information, which is commonly accessed by as many objects of the class as there are, is called as class variable. Class variable belongs to the class. It is not copied in any object. It is not copied in any function. It belongs to the class, and so only one copy of the class variable is maintained, and that copy sits with the class. Class variables are typically used to hold global or shared kind of data. So these are the three levels of variables in Java. Let us take a look at the technical concepts of these variables. So the first one is a class variable, which is the highest scoped variable, and it is also called a static variable. Why so? Because it is declared using the keyword static. It belongs to the whole class. It is declared outside any constructor or method or block. So it does not, like I said, it belongs to the whole class. So the only code block above a class variable is the class itself. It is not written into any method, it is not written in any other constructor, and it is always accessed by all the objects belonging to that class. It is initialized to the default value if no initialization value is given to it at the time of its declaration. And a single copy of the class variable exists, which is in the class itself. We are going to do the same example syntactically, but that time you will have to try and remember these concepts. So this was about the class variable. Of course, it is not copied in any objects. The next one is the instance variable, which are also called as the non-static variables because they are declared without using the keyword static. They belong to the whole class. So when we say they belong to the whole class, it is because they're copied into every object. They're declared outside any constructor, method, or block. Yes, they look very much like the class variables. The only thing that is missing is the use of static keyword. They are initialized to the default value if no initialization value is given. And very importantly, now this is the differentiating factor between class and instance variables. Instance variables have their own copy, so they are copied into every object as their name suggests. If your class has 1,000 objects, there will be 1,000 copies of instance variables, one copy for one object. So while the class variables serve the class, instance variables serve the instance. Okay, so this was about the instance variables. The third level of variable, the final one, is the local variable. They are declared inside a method or a constructor or the block. So they serve that particular code block. They belong to the block, and that is why they are created, they are used, and they are destroyed within the block itself. They are not initialized to the default value if no initialization value is given. So most of the times you have to initialize your local variables or give it some value before you start using them. So these were the three levels, the three types of variables in Java. What we are going to do now is we are going to quickly write a code which will syntactically bring out our bakery example and understand how these variables are put to play. So I am here on my IDE. I'm going to create a new package first, and let me call it chapter 7. Within chapter 7, I'm going to create a new class. I'm going to call it class baker. Okay. In my class baker, this class has baker, what can we say, functionality. Okay, chalo. Then within the baker class, I am going to declare some variables. Pay attention to how I'm declaring it. Now we know that instance variables and class variables are declared at this level. They are not declared in any method or constructor or code block. So I'm going to declare them here. So this is my space for declaring class variables or for declaring instance variables. Okay, now you'll have to remember this when you code your own examples, right? Only if you declare the variable at this level, it will be identified either as class or instance. Otherwise, you will be all declaring local variables. Okay, I want to declare some instance or class variables. Let's see. I say public, static, int. Now this is the data type, total loads. And I give it a value 0. Now, let me take you back and remind you that a class variable is declared using static keyword. Can we draw parallels here? I have declared total lobes variable using the keyword static. So this is my class variable to hold the total number of loaves baked in a day. So this is my blackboard. This is the common area, the common value, the common variable, which is shared amongst all the objects of the baker class. So this is not going to be copied in any object. It will remain with the class because I have given it static keyword. We will discuss these keywords, these non-access modifiers later in our future videos, but you should be able to recollect this discussion that time. Again, please pay attention to the chronology of the keywords here. First is the access modifier, next is the non-access modifier, then we have the data type, the identifier, equal to sign, and the literal. So this is how I have defined my first static variable or class variable. And below that, I say public int individual loads. This again, I'm initializing to 0 and I say this is an instance variable to hold the number of loads baked by every baker. So I am telling my reader that this is an instance variable declared without using the keyword static. So this variable, individual loaves, will be copied into every single object of the baker class. Okay, so my variable declaration is over. I'm now going to put in a business method. Okay, so first let me give it a name and then I'll come back and update my Java doc. Public int, so this is going to return an int value. Bake breads or bake bread. And now, because this is my business method, I will say double, let's say flour. I need some flour, butter, and some quantity of sugar. Let us try to draw parallels with what we see here syntactically to the story that we discussed a little while ago. Every baker goes to the inventory and gets whatever amount of raw material he needs to bake bread for the day. So now the material that the baker requires is acting as input parameters, as arguments to the business method bake bread. So flour, butter, and sugar, these become the local variables. Here, let us say flour, butter, and sugar are the local variables. Okay, and let me just add some Java doc. This method returns the number of bread loaves baked by a baker. All right. And let's say return int. Okay, fine. Let me now start with the method. I'll say individual loaves is equal to flour plus butter plus sugar, let's say into 10 divided by 3, just a random formula. All right. And now because flour, butter, and sugar, all these are double values, and I want them to be fit into an int variable. See, my individual loaves is an int variable. So a smaller variable holding bigger values, I will have to go for typecasting. We discussed this in our previous video. If you have forgotten the concept, please go and check that video right now. Anyways, I'm going to typecast this here int, and now my compiler will not complain because I am finishing the syntax for my compiler. So I have just put some random business formula here. All we want to understand is that the incoming values, which are my local variables, are put down in some way, they are used in some way to deliver my business logic. And my business logic is to bake breads and to return the number of loaves that were baked. So that is how I'm getting here. And then finally, because I want to return it, right? So I will have to make use of the keyword written, and I will return this variable. All right. So this ends with my business method. I'm now going to put in my other business method, public void update total loads. And to this, I will say, I'll pass a parameter. Now my method is not returning anything, so I say void, but it is certainly accepting an argument. It is accepting the number of loaves that was baked. And then I say, total loaves is equal to. So now total loaves is the number that you had put on the blackboard, right? So that needs to be updated every time a fresh batch of bread loaves is baked. And that number will be coming to you from here. So once that number comes in, you're supposed to add it to the previous number so that the number gets updated, right? However, because total loads is a class variable declared using static keyword, the way to access a static member is by writing the name of the class in which the member is declared, followed by the member name. So I'm going to use that syntax, the class name, dot operator, and the name of the variable. So this is what it is. I have updated the number of loaves and I will now print it. Okay. Total loaves baked so far. And I'm just going to print it and I will say baker dot total loaves. Correct? Fine. So my business class is ready. I have a class baker. Inside that class, I have two variables. The first one is a static variable, a class variable, and the other one is an instance variable. I have two business methods. In one business method, I'm using some random numbers for flour, butter, and sugar. Those are my parameters. I send some parameters. I use some formula, which actually doesn't make sense, but still I'm using some formula, and whatever value, int value that formula returns to me, I say, okay, these are the number of loaves that I have baked using this raw material. And I return that number. In my other business method, I take in that number, and using that number, I update my class variable. All right. So this is my baker class. Now let me write one more class, the demo class. The demo class is going to have my main method. So this is my baker demo class now. I'm not going to do too much inside this. I'll just put public static void name string r. All right. And Now, I'm going to create the first baker object. We had 3 bakers, remember? So I'm going to create the first baker. Let's call him baker 1, new baker. Okay, now this is how the object is created. We will discuss the syntax in greater details when we come to object creation and all that. Till that time, let's just stick with it. I'm creating one more baker. This is my second baker object. All right. And now I'm creating third baker. Right? Now every baker needs to get access to the raw material and bake bread. So let me say baker 1 dot bake bread. Now bake bread comes in with 3 parameters. I'll have to specify the quantity of flour, butter and sugar. So let me just say my first baker takes 5.5 kgs of flour and some 2.5 kgs of butter and 3 kgs of sugar. Fine. Now, bake bread method returns the number of bread loaves that was baked. So what I'm going to do is I'm going to capture it in a variable. So I'll just say var baked bread is equal to this. So now this is first baker baking his batch of loaves. All right. Fine. Similarly, I will continue this with my second and third baker. But before that, let me just find out baker 1 baked how many number of loaves, right? This should help, correct? And once I have the number of loaves baked by the baker, I also need to update the count. So I will say baker 1 dot update total loaves, and to that I will pass the number of loaves baked by the first baker. And then I will put out a sys out. I will say total number of loaves in the bakery are, so this is going to give me the total, right? And I will say baker dot total loaves. All right. I'm going to repeat this combination for all the 3 or for the remaining 2 bakers now. Okay. And now this is going to be baker 2. And let me say my baker 2 uses 6.5. All right. I'm really using some weird numbers and even weirder formula. Okay. And baker 2. Right. And I will say baker 2 should update the total number of breads. Okay. Bread loaves. And again, I'm going to baker 3. And now let's say my baker uses 2.5 and 1.0 and let's say 0.5. Okay. And baker 3 baked. And I'll update the number. Yes, so that is how it is. Let me run this program for you and see what happens. What is the output that we get? Okay. So here is the output. The first baker bakes 36 number of loaves. And once the 36 number is ready, so this we are baking it from here. Okay. And okay, let me just rerun it. Okay. Okay, so once this 36 is done, I also add it to the total number, okay, and it gives me the total baker has baked. The total number of loaves in the bakery so far are 36, okay. Then comes my baker 2. Baker 2 bakes again 46 number of loaves, Okay, and this 46 gets added to the previous 36 to give me 82 number of loaves. So it comes from here. Update total loaves here, right? And then I have the third baker baking 13 loaves. This 13 gets added to the previously baked 82, and now I have 95. So as you can see, 36, 46, and 13. These are instance variables. These variables are modified by every instance. Instance 1, instance 2, instance 3. They are specific to the instance, whereas 36, 82, 95. This is the same variable which keeps on getting modified by the different instances because this is a class variable. It is common, it is shared between the instances. So whatever the instances do to the variable, it is reflected across all the instances. Whereas when the instances were baking their own bread, 36 was not reflected in 46 and 46 was not reflected in 13. These were individual copies of the numbers maintained by that instance variable. So this is the difference between the instance variable, the class variable, and whatever amount we used here, 5.5, 2.5, 3.0, this amount was lost after the bake bread method was over. So this was the local variable. These parameters were the local variables for the method bake bread. Now let me quickly do one change to this example. Instead of writing static here, let's say I forget to give static to my common data, or I do not understand. How do I identify that? Okay, this should become static. I remove the static keyword. So now I have two instance variables, total loaves as well as individual loaves. These are instance variables. They are not shared now. They will be copied in every instance. I'll run the same example for you again. Now, before that, I will have to make one more change. I will no longer be able to call this variable using the class name. I will have to use object dot variable name notation. All right. Fine. And again, here as well, I will have to use this. We will talk about this and all these keywords later. Okay, fine. What I have done, I have converted total loaves from being a class variable to an instance variable. And now let me see how my code behaves. My baker 1 bakes 36 loaves and the total loaves is 36. Total loaves in the bakery is still 36. Okay. My baker 2 gets in and completes baking 46 loaves. Now, ideally, my bakery has 36 plus 46. But look at the data that your program is giving you. It says, sorry, total number of loaves in the bakery is 46 because my total loaves only counts the bread that is baked by its own instance and not by all other instances because it is not a shared value. And so it prints individual values which are not updated. On the contrary, in our previous run, we were printing the shared updated values. So this is how you can identify between the data, between the variables that should be common to the class and the variables that should be specific to the method or specific to the objects. Whenever it is, wherever it is, these concepts give you three types of variables in Java, which are class, instance, and local variables per se. All right. So this was all for today's lesson. Thank you all for the love and appreciation which you're showing towards this lecture series and towards all of the videos posted by Ashwas. If you still haven't clicked on the subscribe button and the bell icon, please do so immediately because we really need your support and love. Also, do like and share and subscribe to our videos. Till then, thank you so much.